All right, so we're going to be talking about, well, I put chapters 22, 23, but again, you're not going to need to worry about it, your books at all. We're dealing with organic chemistry. So again, organic chemistry, if we talk about describing it, it's dealing with hydrocarbons, or more specifically, organic chemistry deals with chemistry of carbon-based substances. So organic molecules have carbon in them. Hydrocarbons would have which two elements do you think? Hydrogen and carbon. Not very difficult, right? So organic molecules with that hydrogen and carbon. And so one of the first things we need to recognize is some prefixes. Some prefixes that describe, and you'll see what we use them for in just a minute, but for naming organic molecules. So here are the prefixes, and I've got them already in a box for you. 1 is meth, 2 is eth, 3 is prop, and 4 is bute. These 4 you probably haven't seen before as prefixes. We've seen like mono and di and tri and tetra for prefixes. But organic prefixes, meth means 1, eth means 2, prop means 3, and bute means 4. So again, you probably are already saying, geez, I've seen like ethanol or propanol or isopropanol or butane, those types of things. Those are simply organic molecules that are using these prefixes. The rest of the prefixes you've seen before, I'm sure. Pent for 5, hex for 6, 7 is hep, obviously 8 is oct, non, and dec for 10. So those are your organic prefixes. You have those on the little sheet that I gave you. Now what we're going to take a look at real quickly is the simplest, oh my god, that's the worst. Simplest hydrocarbons are what's called alkanes. And alkanes are simplest because they only have single bonds. They're only single bonded substances. Now what we need to remember from last year, or the year before for like Eileen's case, is that carbon can have how many bonds? 4. You remember the Lewis dot diagrams? We have 4 dots around carbon, which means they're all single dots, which means they all can have a sharing. And obviously hydrogen has how many? Only the 1. So you can see that we're always going to try to pair or share your electrons like this. Carbon can have 4 and hydrogen has the 1. Okay, so just recognize those. So alkanes are substances that are only single bonded. All right, and we'll see what the difference is when we have multiple bonds. But the simplest hydrocarbon is this one with 1 carbon and 4 hydrogens. Okay, that's the simplest hydrocarbon because you got 1 carbon and then you just fill in whatever there would be for hydrogens. Remember that every carbon can have 4 bonds, and then we can just fill them in around. We're going to take a look at a little bit of what, like the structures of some of the sunscreen we made, etc. Okay. Now, this is the simplest hydrocarbon. We would call it CH4. Okay. This would be the chemical formula. This would be, of course, your structural formula. And there you are. Okay? Now, the way that we're going to name these, and I'll erase this in just a second, we'll start talking about naming it, but the way that we name these is use the prefixes that we just saw. So, let me just erase this real quick, and I'll put it right back up when I start to, okay? An alkane ends with the suffix ane. Alkane ends with the suffix ane. And so, realistically, the simple one that we just looked at, this carbon with 4 hydrogens around it, CH4, is, the prefix tells us how many carbons. So the prefix for 1 is meth, and because it's an alkane, it's going to end in ane. This one would be called methane. So methane gas, and you probably have heard of methane gas, is simply 1 carbon with the 4 hydrogens around, and it ends A, N, E. I mean, it's pretty simple stuff. If I have 3 carbons, okay, it doesn't have anything to do with the hydrogens. We don't have to count how many hydrogens. It's only the carbons. So what's the prefix for 3? Prop. And because it's all single bonds, we add the A and E. So propane. That's propane. Now, we need to realize that how many hydrogens around, but we don't really need to put them. So we would have 1, 2, 3, 4, 5, 6, 7, 8. And I hope everyone can see how I got the 8 hydrogens. We have 3 available on this carbon. There are 2 available here, 2 hydrogens here, 3 hydrogens off of this one, and also 3 hydrogens off of this one. And again, it's because carbon can have 4, so there you are. Now, if you remember from last year, you also would have the coming out at you or going behind. Remember this structural formulas right here, where it kind of goes behind or comes out at you. So that would be more specifically what it looks like. We could also call this CH3, CH2, CH3. And you can see, hopefully, we've got our CH3, our CH2, and our CH3. Okay? This right here would be your structural formula, and this would be, of course, your chemical formula. Okay? Now, I'm going to ask you to not even really worry about the hydrogens. Most books and descriptions, if we know it's a hydrocarbon, and we know that we would just fill in the hydrogens around the carbons, then you can just put the carbons. So again, if I wanted to draw butane, how many carbons would I need? 4, because but tells me 4. So 1, 2, 3, 4, and that's it. You don't have to go ahead and draw any of the hydrogens. We'd know how many there are around. There'd be 3 on each of the end ones, right? And then 2 on the middle ones. All right? So that's butane. All right? Let me go ahead and just stop this because it's probably been